All right, cool. So now that we talked about additive inverses, let's go to number 7. By the way, this is page 195. Forgot to write it down. Page 195. Okay. Now this is 3 wholes and 5/6 plus negative 1 whole and 1/6. Okay. Now first thing we want to recognize is, all right, what's happening in this problem? We're adding a negative number. When we add a negative number, we're basically subtracting that number, okay? Because you're adding a negative. So you're kind of taking away, right? So I'm going to go ahead and just turn that straight into a subtraction. Okay, so once we recognize that we're adding a negative number, which is basically subtraction, I'm just going to turn that into a subtraction sign. And now we visually see, okay, let's go straight into subtraction. That's step 1, figure out what the operation is. Step 2, I need to turn these mixed numbers. It's mixed because it's mixing a whole number and a fraction, right? 3 wholes and 5/6 and 1 whole and 1/6. I need to turn that into just numerator and denominator so there's no whole. That'd be called an improper fraction, okay? But the numerator is going to be bigger. And I'll explain why it's called improper in a sec. But so we did step 1, identified the operation. Step 2, let's turn it into just numerator and denominator, okay? Which would be an improper fraction in this case. So we're going to go through our little cycle of multiplying 6 times 3 and then adding 5, okay? 6 times 3, 18, plus 5, 23. So the first fraction becomes 23 over 6. The 6 doesn't change. Minus, remember this used to be plus minus, but when we add negative number of minus, so that's why I changed it. And we go through a little cycle again, 6 times 1, and then we add 1 to that. Right, 6 times 1, 6, plus 1, 7 over 6. Now when we're subtracting or adding fractions, we're only doing it to the numerator, okay? So now that we turned it into, we turned both fractions into improper fractions. Improper just means it's more than a whole. That's all it means. So the numerator is bigger than the denominator, okay? I'm only going to deal with the numerators, by the way. So now we just go ahead with our subtraction. 23 minus 7, 16 over 6, yeah? Once again, denominator stays the same. And now that we got that improper fraction, I'm like, all right, now I need to turn this into a mixed number, like find out how many wholes that makes, because we always have to answer in something called the simplest form, or like the final form, right? Or the reduced form. Simplify and reduce basically mean the same thing, but we want to go as far as we can with the number or with the fraction, okay? We don't want to just kind of leave it the way it is. I can go further with this. I can simplify this or reduce it back into a mixed number. To do that, remember, it's numerator divided by denominator. So essentially 16 divided by 6. You could either do this mentally, or let's just kind of use long division right now. So I'm just going to kind of do my work right here. I always recommend having a work column to do your work in, okay? So remember, 16 numerator divided by denominator, 16 divided by 6. How many times does 6 go into 16? It goes in twice, right? 6 times 2 is 12, right? We subtract that. 16 minus 12 is 4. Now, I'm not making a decimal here, so I don't need to put a point and then add a 0. All I need is how many times it fits in and the remainder. Because watch, this 2 is going to go here, so that makes 2 wholes, right? 2 wholes, yeah? And then the remainder goes on top, and once again, the denominator stays the same. 2 and 4 over 6. Now, don't get mad, but we can reduce this again, okay? I want us to feel really comfortable with reducing numbers. Now, to reduce this, I'm like, all right, by the way, the 2 wholes is going to stay the same, but I need to think of the factors of 4. When we're reducing fractions, we always use factors, okay? So I'm like, all right, factors of 4, 1, 2, and 4. A factor is a number that can make a number through multiplication. What numbers can make 4? Well, 1 times 4, 2 times 2, and 4 times 1. So therefore, 1, 2, and 4 are the factors of 4. Factors of 6 are 1, 2, 3, and 6. Those are the numbers that can make 6. Now, when I'm reducing a fraction, I think of the greatest common factor. So it's a factor they have in common, a number that they have in common, right? And the biggest one that they have in common. So it happens to be 2, okay? So I'm going to divide the top and bottom by 2. That's how we reduce a fraction. We're always going to use the greatest common factor and divide the numerator and denominator by the greatest common factor. By the way, the 2 wholes is going to stay the same. 4 divided by 2 is, 2, so sorry. And 6 divided by 2 is 3. So therefore, 2 and 2/3 is our final answer, okay? Our most reduced answer. Awesome. All right, so let's look at number 9. We have negative 2/3 plus 2 3/8. Now, step 1. We want both numbers to be kind of in the same form, okay? And we want to recognize we have a negative number and we're adding to that negative number, okay? So that's just something we want to keep in mind. But first, let's have them look the same, okay? Now, I just want a numerator and denominator, okay? So the negative 2/3, I don't need to do anything to it. It's already in that form, okay? But the 2 and 3/8, I can. You know, remember, 8 times 2, I go through my little cycle. 8 times 2, and then we add 3, okay? So 8 times 2, 16, and then plus 3, 19. We get 19 over 8. Okay. Now, we can't quite add these because the denominators are different. We can't add or subtract fractions if the bottom numbers are different. So I need to make them the same first, okay? So I need to think of something called the lowest common multiple, which is basically to say, you know, a number that 3 can make and a number that 8 can make, and it's a number they can both make, and like that they both can make, and the lowest one, the one they share. That's the lowest common multiple. So let's look at the multiples of 3 real quick, right? We have 3, 6, 9, 12, 15, 18, and then we stop and let's do the same thing to 8 because we want to see one that they share in common, the lowest one that they share in common. So, you know, we have 8, 16, 24, 32, 40, 48, etc. Okay. Then we're like, all right, we don't see one yet in common. Let's go on with the 3s. Let's see if we have something there. We have 21, 24. Oh, look at that. They share 24. So then we kind of circle the 24 or keep it in our mind if you do it mentally. And that number is going to be the denominator, okay? So the lowest common multiple, which is what we just identified, right? A number they can both make, yeah? And the lowest one that they both have in common, right? Which in this case is 24. The denominator has to be 24 now. So we just need to change it to 24. How? Through multiplication. So what do I need to do to 3 to get 24? I need to multiply it by 8, but I have to do the same thing to the top. Whatever you do to one part of the fraction, you have to do to the top part, okay? So I'm going to multiply that by 8 as well. Now I need to multiply 8 by 3 to get 24, because remember we want our denominators to be 24, right? The lowest common multiple. Lowest common multiple. Now I'm like, all right, I have to do the same thing to the top, right? Whatever I do to the bottom, I do to the top. Awesome. Now I'm gonna erase this for a sec, just so we have some room. So this turns into, we have negative 16 over 24 plus 57. 57, yeah, 19 times 3 is 57, and over 24. Okay, cool. I always want to check my mental math. Okay, cool. So, cool. So we got negative 16 over 24 plus 57 over 24. Now remember, when we're adding or subtracting fractions, we only want to do so to the numerators, okay? We don't have to touch the denominators. So we have negative 16 plus 57, which is to say, all right, 57 minus 16, and you keep the sign of the bigger number. Just a quick reminder, imagine you're at negative 16 on the number line. If you add 57, you add 57, you're gonna well past 0, right? You're gonna get into the negative area. So you're essentially taking 16 away from 57, and the answer is gonna be positive because you're gonna pass 0 into the positive zone, right? So 57 minus 16. Let's break here 10 into 10 and 6. 57 minus 10, 47 minus 6, 41. So 41 over 24. Alright, cool. So positive, perfect. So now we have 41 over 24. One final step now. We just need to turn 41 over 24. Once again, I always have to check my mental math. I wouldn't want to make a mistake in the video and then, redo it because I don't know how to edit. Okay, perfect. Cool. So I'm like, all right, 41 divided by 24 essentially, yeah? 24 goes one time into 41, goes one time, and our remainder is, let's see, 24, 34, 34, 44. Okay, so essentially 17, hang on. I hate messing up my mental math, so I'm just gonna, okay, yeah, 17. Okay, cool. So 17 over 24. Cool. So 1 whole and 17 over 24. And we automatically should recognize that we cannot reduce that because 17 is a prime number. So it doesn't share any other factor in common with 24, right? Like if I were to be like, all right, let me try to reduce that. The only factors of 17 are 1 and 17. 24 has a number of factors, right? 1, 2, 3, 4, 6, 8, 12, and 24. But the only factor they have in common is 1. So can't really reduce it because 17 divided by 1 is 17, 24 divided by 1 is 24, so it's just going to stay the same. So that is the most reduced version of that. So so awesome. So we just solved number 9. Okay, would like to do one more before we go on to 4.3. All right, so let's look at number 11. We have negative 3.7 plus 1/4. Now, we always have to keep both rational numbers in the same form. So they both either need to be decimals or they both either need to be fractions. In this case, we have a decimal and a fraction, so I need to change one of them, okay? I will say that decimals tend to be easier to deal with, because with fractions we have to make the denominators the same and, maybe turn them into, go from a mixed number to an improper fraction, make the denominators the same, and then turn it back into a mixed number. It's just like all these steps, right? Decimals are a little bit more straightforward. Okay, I'll get into the nuances later. I need to see if, all right, can I turn 1/4 into a clean terminating decimal? Like, if 1/4, by the way, turns into a decimal with a bar on top, remember we talked about bar notation in section 4.1, I have to turn them as fractions. Okay, I can't add numbers with a bar notation because it won't give me a very accurate answer. Okay, so I'm like, all right, I wonder what 1/4 becomes. I would like us to try to recognize that certain fractions are always certain decimals. Like 1/4 is a quarter. Think of a quarter like money. 0.25, 25 cents, right? So 1/4 is 25 cents. But let's kind of do it to like prove it the long way, right? Numerator, let me just do my work here. Numerator divided by denominator, 1 divided by 4. 4 can't go into 1, I put a 0 there, 0 there. 4 goes 2 times into 10, 4 times 2 is 8. We subtract that, 10 minus 8 is 2. I add a free 0. 4 goes 5 times into 20, 4 times 5 is 20. We subtract that and we're good. So 0.25. Nice clean decimal, doesn't have a bar, so therefore I can turn it into a decimal and just add the decimals and call it a day, right? Okay, so let's do that. Here, so we're going to turn this. This is going to become the negative 3.7 is going to stay the way it is. Okay, we don't have to change that. Plus 0.25. Cool. Now remember, when we add to a negative number, we're kind of subtracting, because imagine you're at, I mean, that's the trick, right? Even though you're technically adding, right? Imagine you're at 3.7. If I'm at 3.7, which is like, let's say here's negative 3, negative 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7. That's 3.7. And then, 3.8, 3.9, and then 4, just to really show you what's decimal, right? Anyway, so yeah, 3.7. If we add 0.25, if we go that way 0.25 times, or at the 0.25 spaces, we are adding, but the digits are going to get smaller. So the key is, we're going to subtract, but we're going to keep the negative sign because we're still going to be in the negative area. So always keep the sign of the bigger number, or the bigger absolute value. Okay? Absolute value is the distance from 0. Just think of the bigger number, right? Or the bigger digits, right? So we keep the sign of the bigger digits, so we subtract and keep the negative sign. So we know that it's going to be negative. We know that for sure. And then we just go ahead and subtract. I'm just going to subtract 3.7 minus 0. Always line up the decimal points, always, or else you'll get a different answer, okay? Minus 0.25, put a 0 in the blank spaces, okay? We go ahead and subtract. So I'm like, all right, can't do 0 minus 5, this turns into 6, I get a 1 there, this turns into 10, yeah? Right, 10 minus 5 is 5, 6 minus 2 is 4, drop the decimal point, and the 3 comes down, so negative 3.45 is our answer. Okay, I promise one more, because the thing is, this actually shows a really kind of important example of something about turning both into fractions and not both into decimals, because this turns into a bar notation. I just want to show you how to turn a decimal into a fraction real quick. Okay, but always feel free to stop the video if you're like, all right, I got what I needed or something. You can move on at any point. I'm just doing these examples to give you some examples and for other problems that you have or other questions or something. Okay, cool. I just try to do an example of each type. All right, except for the word. I can't do the word problems on these because I just simply don't have enough space. So I try to do those in class. Always ask me questions about those. But one day I hope, maybe as I get more, if I keep doing this, maybe I can do word problems on the screen somehow. I'll figure it out, but right now we're just doing the number problems. So remember, both need to be in the same form, okay? I'm like, all right, cool. So let me try to get them both into decimals, just because decimals are a little easier to deal with than fractions, right? So I'm like, all right, let me see what happens with 1 divided by 3. Let me try to turn that into a decimal. 3 can't go into 1, 0. 0, 3 goes 3 times into 9, and we do that. But look, it's going to keep repeating. Look, we're going to get a repeating decimal. So it's going to be 0.3 bar. Now, if I get a repeating decimal like that with a bar notation, I have to turn them both into fractions, because that's not going to give me an accurate answer if I add it to 4.1. I want an accurate answer. So I'm going to turn them both into fractions. Okay, so the 1/3 is going to stay the same. 1/3 is going to stay the same. 1 over 3. Can you see? No. Now, to turn this into a fraction, remember, this is 4 wholes. 4 wholes. And then you look at whatever's after the decimal point. You look at the digit that it ends at. So it ends at this digit right here, 1. You're like, all right, the 1 is in which place is it in? It's in the 10ths place, okay? Everything has a lisp after the decimal point, 10ths place. So I'm like, that is the denominator. The place that the digit ends at is the denominator, and then whatever digit it ends at is the numerator. So 4 1/10. Okay? Cool. So now we're in business, and you can proceed with this as we did with the previous one. Since we started, I'm just going to finish it. Go ahead and end this video and keep doing your thing if you're comfortable with this. But remember, I'm just going to, my next step is I'm going to turn them both into same version of a fraction, so just numerator and denominator. In this case, it's going to be an improper fraction, right? 4 times 10 plus 1, that's 41 over 10. Got to turn them both into the same denominator. Lowest common multiple, or lowest common denominator, is actually 30. Okay, so I have to make them both 30. I'm going to multiply this by 10, multiply this by 10, multiply this by 3, multiply this by 3. This becomes 10 over 30 plus 30, 80, 120, 123 over 30. Okay, cool. I just want to make sure. Okay, now we just add these, right? 10 plus 123, 133 over 30, and then we're like, all right, then we just go ahead and divide. How many times does 30 go into 133? 30, 60, 90, 120, 150, so it goes in 4 times with a remainder of 13. Okay. 4 and 13 over 30. We cannot reduce that. We cannot reduce that because 13 is a prime number. Okay? I always want to double check my work here. Okay. Perfect. Okay. So, all right, that's your final answer there. See you in section 4.3, which will be subtracting rational numbers. Cool.